Cancer. What is it? And why is it dangerous? Over the next 5 or 10 minutes, I hope we can explore what makes a normal cell become a cancer and why it is dangerous to us. But first of all, let's look at what makes up the human body. And the human body is a very complex system made of many different organs, many different cells, and you see here various different types. And yet, we all follow the same shape, roughly the same size. Our organs perform roughly the same activity, and we're put together as this amazing piece of equipment that produces what we know as the human body. And it's a miracle. It's a miracle that it all fits together, and it's a miracle actually that more of it doesn't go malignant, because every day we are producing lots of new cells to replace those that have died. And every day our genetic material acquires damage, and it's that damage that can make a cell change from a benign, useful cell making up an important structure, replacing a previously dead cell, to a malignant cell that's going to grow out of control and cause us serious harm. And here we see another example of the miracle that is the human body, and indeed any biological system. You see there in the top left-hand corner a human embryo, just a few cells. And those cells grow, and they grow rapidly. Over 9 months it produces a human infant. And yet those cells grow in different places, in different shapes and different sizes, to different structures and different functions, all controlled by the genetic material inside each cell. At the bottom there you see the amazing process, which is that which produces a human hand. A little bud that then produces the fingers, and the fingers that then grow, but they grow to a certain size, then they stop. It's programmed to produce something of a certain size and shape, and those programs are found inside the DNA of each cell. So what's the problem with cancer? Well, the problem is that in a normal cell, in the top left-hand corner, it grows and it divides, and there's a population of those cells making up a certain part of our body. Each cell divides into a daughter cell, and at some point they stop growing because they've reached the required number to function as that organ. Some cells will be recognized as damaged cells, you see there, and they'll go into a process known as apoptosis, which takes those cells out of the system. Similarly, other cells will just become old. We have what's called senescence, and those cells just disappear out of the system as new ones come and replace them. All a carefully balanced process. What happens when we have a cancer cell? The cancer cell starts as a normal cell. That normal cell divides into 2 daughter cells, but one of them may be abnormal. In one of them it may have lost the ability, for example, to undergo apoptosis, in which case an abnormal cell perpetuates, and it provides a source for more abnormal cells. And there you see the problem. Abnormal cells which have lost their control function, dividing multiply to produce an uncontrolled mass of cells, which becomes the tumour, which becomes the cancer, which then becomes a potentially fatal condition. And this is because we have control of those genes. We have an on switch and we have an off switch. And if you look on the right, the on switch are a set of genes known as oncogenes. And when they're active, they stimulate growth pathways. A simple on switch to growth. And they're controlled by another set of genes which are called tumour suppressor genes. And they're the off switch. When they're activated, you switch off growth. They suppress that excess production of cells which produces a tumour. So we have this careful balance between oncogenes and tumour suppressor genes which keep our normal cells in balance. But when we have a cancer, the oncogenes are more active, the tumour suppressor genes are reduced in activity, and then we have an excess production of cells making that cancer. So all our cells contain genes made up of DNA. Damaged genes malfunction, and all our cells are damaged all the time from different noxious agents that we happen to encounter during the day. Usually they're repaired, but not always, or that repair capacity is defective. And then we get these abnormal cells where there may be overactivity of oncogenes, underactivity of tumour suppressor genes, and that leads to uncontrolled growth, and that leads to a cancer. So why do genes get damaged? Well, there are a number of ways in which they can get damaged, and these are the causes of cancer. Of course, you may be born with some abnormal genes, and some families are unfortunate enough to carry those genes, and we see cancers arising through the successive lines of those families. And then there are other causes we encounter in the environment. Common examples are on the left: radiation damage. You know that X-rays can cause cancer. Of course, we balance that because you need a lot of X-rays to cause cancer. But very low doses of X-rays can actually help diagnosis, help us become healthy people by finding abnormal function. So we have to balance the use of X-rays in the medical setting, balancing always the benefit against risk. Radioactivity, which is all X-rays produce, is also a danger when it comes to radiation damage. That's why there's very close control of radioactive material, because too much exposure to radiation can cause too much damage to your DNA, and then that potentially causes malignancy. We've learned a lot about that from survivors from the atomic bombs and from Chernobyl and other radiation accidents, where there's unexpected and unintended exposure to radiation, and we see cancers develop many years later in those populations. Viruses are another example. You will have heard of human papillomavirus, HPV, mainly because now we can immunize against it. It's the common cause of cancer of the cervix. If we immunize young girls against HPV so they're not infected, then we can eradicate cancer of the cervix. And there are other examples. Hepatitis B is one which predisposes to liver cancer. And then on the right, of course, we are exposed to many chemicals. The most common still, unfortunately, is that many people continue to smoke cigarettes and tobacco. And they are a potent cause of carcinogens, the chemicals that cause cancer, coming into our system. There are others as well which are found in certain industrial processes and which, once we know about, we can regulate carefully, but are still recognized as potential causes of cancer. And it's important to realize we get minor damage all the time. We can't avoid all these agents in the environment, but by and large it's repaired. It's when we get multiple damage, multiple sites of DNA which is broken, as you can see here, or it's swapped around so it malfunctions in its coding. When it's allowed to accumulate, then we have trouble, and the trouble is the cancer. So why is cancer dangerous? Well, you can see we've got uncontrolled growth of cells, makes a lump. That's not particularly dangerous, but it gets bigger and bigger. And as it gets bigger, it can interfere with normal structures and function. These cells are often more hardy than normal cells, and they learn to develop a new blood supply with oxygen and nutrition, so they become independent of where they started. And the real problem is that cancer cells can spread. Most cancers that start in an organ and stay there, it is possible to cure them by removing them by surgery or radiotherapy. Once the cancer spreads, that's when we have a serious problem. That's called metastasis or secondary cancers. And you can see here an example of the common problem coming from the bowel, going to the liver and the lungs. The problem is that cancer cells learn to escape from their origin. They spread by entering the bloodstream or the lymph circulation, and reach other parts of the body where they set up new colonies of cells, so-called secondaries or metastases. And then the body is taken over by this progressive growth of these uncontrolled cancer cells. So, cancer, what is it? It's uncontrolled cell division, which leads to uncontrolled growth of the cell population, which makes a lump. The lump is the tumour. You can see an example of a lump in the neck on the side there. Why is it dangerous? Well, two things can happen. As the lump gets larger, it can damage organs around it or affect their normal function. It can block the bowel, it can block the kidneys, it can block the lung function. And then, more commonly and more seriously, some cells develop the ability to migrate into the circulation and set up new colonies in other organs, so-called metastases, which also grow in an uncontrolled way, and progressively they take over the body. And sadly that then becomes a fatal condition. So I hope over the last few minutes you've seen the reasons for cancer cells developing, the abnormal control of their growth which results in them forming a cancerous lump, and then the serious consequences of those cells acquiring the ability to travel afar and set up separate colonies throughout the body.